Okay. Uh, this is also a typical question is when you're selecting, this is question 3, part 1. Selecting a sample, and then they tell you, they give an example, and they want to know which method did you use in selecting the sample. So according to this, the survey of junior high school in Halifax. So they're looking for junior high school students in Halifax. They could do it multi-stage, they could do it volunteer sample, convenience, systematic. They could do it cluster, simple, random, or stratified. I'll talk about all of them, and then we'll see which one is the one we need. Now skip A because it should be the last one to talk about. B. You could do it as a volunteer system. For example, let's say you want to do the study, you want to pick students from junior high school. So what you need to do, what you decided to do is you posted an ad and you asked people, come join us to do this. So you're asking people to volunteer. So anything, when they give you the scenario and it looks like there was a process of asking people to volunteer, there would be a volunteer sample. Convenience sampling is, instead of doing this ad, you decide, well, why don't I just go to my building and ask all the students or junior high school students who live in the same building or live in the same area. So you want to do it the easiest way or quickest way. You don't want to spend time or effort, you want to do it the easiest way. In this case, we call it convenience. Systematic. Systematic is when you put the information in a certain system. For example, you put the names in Excel and you decide to select every 10th name. So put in a list and select every, say, 10th name, 50th name, 100th name, anything that indicates that you're going to put them in order and select every 10th name. That's called systematic. There is cluster and stratified, so that's E and G. I still need to talk about A and F. I'm talking about E and G together because they're related. One is called cluster, one is called stratified. In both of them, there is some kind of division. Divide them into groups. And that's for both cases. So let's say junior high school, you divide them into Canadian, international. So you divide them into 2 groups. So if you divide them, and that's for both of them, cluster or stratified. They tell you you're going to divide them into groups, and you're going to pick everyone. For the cluster, you're going to pick everyone in the group. But for stratified, after you divide them, you're going to pick some from each group. So if you see a division and you see that you're selecting some, that would be stratified. If you're selecting all, that would be cluster, of course, after the division. Now, F is the simple random. And that's when you do it right, no restrictions. And that's the perfect way to do it, pure random. So you select, I tell you do a study in junior high school, so you randomly select 50 high school students. So they tell you what you need to select without telling you exactly that you did it in a certain way, just pure random selection. And the first one is multi-stage. where you combine 2 or 3 of these. So you start doing it volunteer, and after you get the names, you put them in a system and you pick every 5th name or 10th name. So you do combine 2 of these. So now let's read the selections. Again, there is one mistake here. We'll figure out which one after we read. So the first one, go to the high school, number 1, go to the junior high school closest. So that's, again, indication that you want to do it the easiest way. So you go to the high school closest and speak to 100 students. That's the quickest way, that's convenience. So the answer is C for number 1. That's right. You choose 3 junior high school in Halifax and speak to all. See, high school in Halifax, there are a lot of them. You only select 3, so you're gonna do a division. So your division, it doesn't mean that you're dividing them only, it means that you actually pick few of them. So you divide them into, say, Halifax, West, North End, South End, that would be considered division. Or you pick 3 high school, and then you pick all of the people. So you pick 3 high school, and all, that would be clustered. Cluster is the answer number 2, and they got it right. Select a sample of 200 from Halifax. See? Just select a sample 200. No restrictions. That's the right way to do it. The last one is the mistake. So randomly choose 5 schools so that we consider this division. You're only selecting a group. And select a random sample of 30. So you're selecting a group, there is division, you're selecting some of the total, and you're selecting some people, only 30 from each. That's stratified. And that's 4. They picked A multi-stage. There is no multi-stage in here. The answer is stratified. Good? Part 2. If you read it, they tell you that they want to see workers who use monitors at their job, comparing the monitors between old and new. In line 2, they select a sample of 100 data entry clerks. In the sample, they found 44 of them using the monitors that's less than 1 year, so the new one. So you have 100 data entry clerks, 44 use new, 56 use old monitors. What else? Now, after 2 months, each worker was asked if they missed more than 3 days of work in the past 2 months due to eye strain. It was found the percentage who missed more was much lower for the group listed. So they asked people, workers, if they missed work due to eye strain or eye problems. And this one, the people using new, was much less than the people using old. This is the story. And the first question, identify everything. Population. When they ask to identify the population, look at your story and where they say the sample. It's 100 data entry clerks, sample of 100, so all you need today is replace the 100 by all data entry clerks. So just replace the number by all, and that would be your population. And sample, we put it with the numbers. So the sample would be the 100 data in 3 clicks. And then you need the response, the explanatory, and the parameter. Response, if there's a response, then there must have been the question. What's the question here? They're asked if they missed work days to I problem. Response, if this is the question, if whether they missed or not, the response would be missing days of work. So the question, response is the response to the question, and the question asks whether they missed work or not, so missing days of work. So that would be the response. Explanatory, this answer would be explained to due to I strain or problem from using old or new monitors. And parameter, it's either average or percentage. And if you remember, they say in the question the percentage of people missing work days and the people who are using new was much less. So parameter would be percentage of workers missing work days from those using old and those using new monitors due to eye problems. So this is basically how you do everything for this. And after this, explain why this is a prospective observation study. When you made prospective means that there's a waiting period. So you're doing the test and there's a period of a waiting period. Remember in the question when they asked that they waited 2 months, I believe. Yeah. So after 2 months, each worker was asked if they missed. So they waited 2 months. So that made it prospective. Prospective because there was a test and waiting period to get the answer. Waiting period to get the response. Okay. Give a possible confounding or lurking variable in this problem. Confounding means that can you think of something that might have affected, okay, like for example, they missed work days. You assume, or in the study, they assume that they're going to miss work days due to eye problems. But lurking variables, other reasons for answer. So this is part C, meaning you can make up anything. Maybe they missed work because of personal problem. Maybe they missed work because they were sick or flu sick. Maybe they missed work. So other reasons for missing work not related to the eye problem. Those other reasons, we call them confounding variables or lurking variables. Other reasons that could have affected the answer, not necessarily the fact that they're using new or old. So come up with any reason that could affect the answer other than the one in the study. And D, they're going to tell you a story, and this is definitely in the exam. They'll tell you a story, and then they tell you the 4 principles, or they pick 2 or 3 of them. I'll talk about the 4. The 4 principles of experiment satisfied. The 4 elements of experiment: randomization, blocking, control, replicate. So, I'll talk about them in general first. Randomization, let's say you select 90 students. They must say select 90 students, and they must mention randomly. So if they mention that the selection was done randomly, you have randomization. 90 students, blocking would be dividing the 90 into groups. So let's say 30 get no help, 30 they get help from teacher, 30 get help from tutor. You divide them into groups. Anything that indicates that you're dividing them into groups. Control, in the division, you see when I said help from teacher, help from tutor, I did one of them the no help. That would be your control group. Control group is one of those groups that get nothing. So we can compare the nothing to the extra, to the people who are getting help from the teacher and the people getting help from the tutor. Replicate means that every person in this group, every unit, it could be a person or whatever the sample is, every unit must be treated the same. So let's say when you select the 30 and you want to test them, they have to be given the same test. And you put them in the same environment. And when you do this for the 30 here, you have to put them in the same environment. So, and that's basically how you talk about it. So now they give you the scenario here, and they tell you, are the 4 principles or elements of experiment satisfied? So let's see. Researchers decide to modify the study. They select 100 clerks before, but now randomly, the first one is satisfied. Assign 50 to use monitors less than a year, so new monitors, and 50 using the old. So there is blocking. 50 all using new, and 50 all using old. And the fact using old, that will be your control group. So 3 of them satisfied. And then they tell you, explain whether or not the following principle, whether or not the following principles. Randomization, of course, it's satisfied because selection was done randomly. Replication study is done on more than one click, but entire study is done at once. No, in the replicate you see what this unit or every person or every unit must be treated the same in each group. That's a better way of explaining it. And there was no mention of this directly, but you can say, you can assume that it's just there is nothing that indicates that something was different or treatment was different. So you can say it's safe to assume that every unit must be treated the same in each group. Okay, this is it for this question. We go to question 4. These days, it probably comes as no surprise that 16% of Canadian adults no longer watch any conventional TV, and they only do it online. So we have a percentage, 16% people who watch stuff online. We plan to study sample of, so we took a sample of 130 Canadians. And asked them how they watch TV or whatever. For the purpose of this study, you may assume the sample normal model and the assumptions all satisfied. Question 8. Find the mean and standard deviation for sample proportion. So you need mean for sample proportion, p hat, and standard deviation for sample proportion, sigma hat. Mu, or average of sample proportion, would be whatever the percentage given. But the sigma for sample proportion would be the sample proportion 1 minus sample proportion over n. So it would be 16, 1 minus 16 over the sample 130. And the answer is 0322. That's your sigma proportion. So I'm going to add them here. So mu proportion of this, now sigma proportion of sample proportion is 0322. Using the approximation rule, find the 68% probability of the sample proportion. Now, they could ask for the 68, they could ask for the 95, or the 99.7, one of the 3 levels. In your case, you're asked for this, but I just want to show you what it's supposed to be. So in the 68, range would be mu minus sigma, mu plus sigma. Mu minus 2 sigma, mu plus 2 sigma. Mu minus 3 sigma, mu plus 3 sigma. So 16%, sigma say 3%, and here's 16 plus 3. And that will give you 13 and 19. And that's the answer for the question, if you see, yeah, 13, 19. If you're asked for 95, then you take the 16% mu, you minus 2 of these. So you minus 0.6, and you take the 16 and you add 2 of these, you add 0.6. That will give you 10%, 22. And if you ask for 3, then you'll add the 3% 3 times. So that would be 16 minus 0.9 and 16 plus 0.9. But they only asked for the 68, so we only do the first one. Question C. Find the chance probability that more than 25% of Canadians no longer watch. Percentage that the P more than 25. So we go here, the middle point would be your mu P. We found this to be 16% at the Z line 0. You're looking for more than 25. 25 must be here, more, you shade the more. In order to do this, we need to switch everything to Z, and the equation here is P, mu P, sigma P. This is 25. Mu P is the 16 we found in A, and this one was 322. If you do this, roughly the Z number would be 2.81. So if you put everything in the equation, it would be P more than this. The equation will give you 281, so more than 281. And I told you, I still have the 3 cases here. More, your answer is 1 minus whatever this is from the table. So you go to the last page where the table is, and you find 281. So in the positive, you need 2.8, the first number after decimal 1, in the second decimal place. 2.819975. So you're 1 minus 9975, and that will be 0025. That's it for question 4, I believe. And we go to question 5. But before question 5, I'm gonna stop the video, and that will be in part 3.